This will be our test 2 review for intermediate algebra. This will be our key here, our answers. So perform the indicated operations and simplify. So when I look at this, I see two parentheses, right? I got a parenthesis here and a parenthesis here. But what I'm really looking for is what's between them. And what is that right there? A plus sign, which means I'm adding them. So if you add two parentheses, a plus sign doesn't change it. So what I do is I'm going to line them up vertically. The first one doesn't change. The second one, if I cover this up, what kind of 3 is that? It's a positive. So I put a plus there, not because of this, but because of that 3 being positive inside there. Plus 3x squared, plus 13x, and then minus 1. We don't change anything whenever there is a plus sign between there. Do not multiply those out. I will not ask you to multiply 3 terms times 3 terms. You'll be here till Christmas trying to do that. I'm not asking you to do that. So then this is going to be 4x squared plus 9x minus 12. Because again, 1 plus 3 here is 4. We have negative 4 and positive 13. Different signs, subtract. 13 minus 4 is 9. And then bigger number is 13 is positive, so plus 9x. And then both these are negative. Add them together, get 12. Keep it negative. And then I'm going to put my answer in the answer box. Over here again, to the right of this one, I have a plus sign again, which means I'm adding. That's the first thing I look at. What's between the parentheses? It's going to tell me what to do. So then x squared minus 23xy plus 18y squared. Then I have, don't worry about this, I have a negative. That means that I have what kind of 6x squared? Minus, don't change it. Then I also have a minus 17y squared. I don't have over here any xy terms to put right here, right? So I just leave that space blank. So then I'm going to come down here and say, what is 1 and negative 6? Well, they're different signs. 6 minus 1 is 5, and they're x squareds. And 6 is bigger than 1, so it's negative 5x squared. Then we just simply bring this term down. There's nothing under the negative 23xy to change it, so it's minus 23xy. And then plus 18 minus 17. Again, 18 minus 17 is 1, so this is plus y squared. Plus y squared. And I need to put that in my answer box. So negative 5x squared minus 23. And some of y'all are going to write it straight in the answer box, and that's fine as well too. And then over here, look at the next one. 9x squared minus 3x minus 10. Then what's between the parentheses? A minus sign. That means I'm no longer adding, I am subtracting. Nothing is in front of the first one, so it doesn't change. We're going to have 9x squared minus 3x minus 10. But then I take this negative and I distribute it to all 3. So this is positive 7. So guess what? It becomes negative 7x squared. This is a plus 8 times this negative gives me what? Minus 8x. It changes that plus to minus. Then this negative with this negative gives me a plus 5. A plus 5. So 2x squared minus 11x, and then what? Minus 5. Again, 9 minus 7 is 2. Negative 3 and negative 8. Add them together, get 11, keep it negative. And then a negative and a positive, you subtract. 10 minus 5 is 5. Bigger number is negative. So 2x squared minus 11x minus 5. And then the last one on this screen, again, there's a minus here. So guess what? I'm subtracting. All right, be sure you look at those, y'all. I have people every semester who will multiply all 4 of these, and the hour's up. I go back to check on them. Everybody else has been gone for 20 minutes, and they're sitting there still on the 4th problem because they've been multiplying. Don't multiply this. There's a minus sign here. So 9x squared plus 4x plus 9, and then distribute the negative. So then that 8 is positive inside here, so it's going to become negative. Negative 8x squared. Then negative x, and then plus 4. All the signs change. So often I see students, they'll put the minus 8x squared, and then they put plus x minus 4. You got to change them. You got to change all of them. So then that's going to be a positive x squared. 4 minus 1 is plus 3x, and then plus 9 and 4 is 13, so plus 13. So x squared plus 3x plus 13. Then we come down here, we have 5x squared, and then parentheses, we have times. Now look, what's between the x squared, the 5x squared, and the parentheses? Nothing is here. That tells me they are being multiplied. So when I multiply a single term times 3 terms, that is called distribution, right? So I'm going to distribute the 5x squared times all 3 terms. So that's going to be 30x to the 4th, and then minus 15x to the 3rd, and then plus 10x squared. So 30x to the 4th minus 15x to the 3rd plus 10x squared. And I have first, outer, inner, last. This is 2 terms times 2 terms. This FOIL, first, outer, inner, last, right? 3x times x is 3x squared. Then I have the 3x times that was the first one. 3x times the negative 6 is negative 18x. That's the outside or outer. The inside or inner is the positive 7 times x is plus 7x. And then the last in each one, the plus 7 times the negative 6. Positive times negative is negative. 7 times 6 is 42. And then I have 3x squared. I have my minus 42. And in the middle, what is a negative 18 and a positive 7? Well, they're different signs. So 18 minus 7 is 11, and they're x's. And the bigger number 18 is negative, so it's minus 11x. So then 3x squared minus 11x minus 42. The next problem is 3x plus 5y in parentheses squared. When you square something like this, you can just write it down twice. 3x plus 5y times 3x plus 5y. And when I do that, guess what? I have 2 terms times 2 terms. We call that FOIL. Right? Most of us are really familiar with FOIL. So we have first, outer, inner, and last. That's going to be x squared. Then we have plus 15xy. Then we have plus, oops, I'm going to put it underneath it because it's a like term. The inside here is going to also be plus 15xy. And then the last is going to be plus 25y squared equals 9x squared plus 25y squared. And then the middle terms are plus 30xy plus 30xy. So 9x squared plus 30xy plus 25y squared. Next problem, 8x minus 9, 8x plus 9. Again, it's 2 times 2, so FOIL. First is going to be 64x squared. The outside is going to be plus, because it's 8x times a positive 9, 72x. Then we have a negative 9 times 8x in the inner here. That's going to be minus 72x. And then negative 9 times positive 9 is minus 81 indeed. So that's going to be 64x squared. These 2 terms here, plus 72 minus 72. If I have $72 and spend them, I got 0. I got it canceled. Right, it's done. My money's canceled. Then minus 81. So that's going to be 64x squared minus 81. Just going to write that in my answer box here. And again, I have 5w minus 2 squared. Again, I'm going to take this and write it as 5w minus 2 times 5w minus 2. First, outer, inner, last. Again, first, 5w times 5w, 25w squared. Then we have outer minus 10w. Inner, another minus 10w. They're like terms. And then plus 4, right? Negative 2 times negative 2 is positive 4. Then we have 25w squared. And look, both these are negative. I add them together. 10 plus 10 is 20, and it's w's, right? That's what it's like. And it's negative. You keep it negative when you add them together. and then bring down my plus 4. So 25w squared minus 20w plus 4. So we have 2 terms, x minus 2 times 3 terms. So this doesn't have a name, but you take the x and you distribute to all 3 terms. So the x times the 3x squared gives me what? 3x to the third. Then we take the x times the plus 7x and we get plus 7x squared. Then we finally take the x times the negative 4 and we get minus 4x. And that takes care of multiplying the x times all 3 of these things over here. Okay? So now what do? I go back and take this negative 2 and I also distribute it to all 3 things. So negative 2 times 3x squared is negative 6x squared. Notice I put that under my x squareds because those are like terms. And then over here I'm going to say negative 2 times a positive 7x is negative 14x. And again, that's a like term with that one. Put it underneath it. Negative 2 times negative 4 is positive 8. Don't have another term like that, so just stick it on the end out there, right? Equals 3x to the third. Then a positive 7 and a minus 6. 7 minus 6 is 1, and it's positive, so positive x squared. Both negative here. What do? We add them. 4 plus 14 is 18. What makes them alike is x, and they're both negative, so it's minus 18x, and bring down my plus 8. So 3x to the third plus x squared minus 18x plus 8. So long division, synthetic division. Let's see. What goes under my house here for long division? I have x squared minus 12x plus 27 and x minus 3 on the outside. And the thing that I ask myself in long division is, I look at x and x squared and I say, what do I multiply by x to get x squared? That will be x. Another way I could look at that, I could say x squared over x. I could take this and put it over this, right? Here and here. That simplifies. What does that simplify to? Just x. So then I take that x and I multiply it by both of these things. X times x right here is what? X squared. X times negative 3 is negative 3x. So I'm going to take all that off there. But that's what I'm doing. I'm distributing that. I'm taking this here and getting x squared. I'm taking this here and getting minus 3x. And then what do? That's right. I change my signs. Minus here, plus here, because I'm subtracting. X squared minus x squared cancels. If this first column doesn't cancel, then you messed up. Put a Band-Aid on it and start over, right? So then negative 12 plus 3, right? Different signs. What is 12 minus 3? 9, and then this x's, right? And it's negative because 12 is bigger. Bring down my plus 27. Then I start the process all over again. I say, what do I multiply by x to get negative 9x? Well, that will be negative 9, right? Negative 9 times x is negative 9x. Negative 9 times negative 3 is positive 27. But wait a minute, what do? Before I combine those, I change my signs. Make that plus, make that minus, that cancels, and that goes to 0. It also cancels. That's my remainder. So my answer is simply what? X minus 9. There's no remainder, so don't worry about putting something over this or that or whatever. It doesn't matter, 0. Remainder's gone. And then synthetic division. Now remember, this is where my house is flipped over upside down and it's got a porch on the front of it. This down here is the only sign we change. If I change that, it's going to be a positive 2 on my porch. It's going to be a positive 2 on my porch. So then inside here, I take the coefficients 2, 5, negative 6, and negative 11. Let me circle those negatives. Negative 6 and negative 11. So we get 2 for the x cubed. Then we get a 5 for the x squared, then a negative 6 for the x's, and a negative 11 for my constants, right? Erase that so you can see it and make sure I did that right. So 2, 5, negative 6, negative 11. And I have to have everything accounted for. There's nothing missing, so I don't have to put any zeros in. No placeholders. Bring down the 2. You always, in synthetic division, bring down the first number. 2 divided by 2, 2 times 2, you multiply. Porch times the basement, write it in the first floor. 2 times 2 is 4. Then what I say add, I just mean don't change the signs. So if 5 and 4 are both positive, you get 9. Then you start the process over. 2 times 9 and write it right here. What is 2 times 9? That's right, 18. And then you got 18 minus 6, right? Because a negative 6 and a positive 18 is 12. Then you got 2 times 12 and write it there. Same process over and over again. That's 24. What is the negative 11 and positive 24? It's 13. That represents my remainder. So how do I write that? Well, look. This started with x cubed. You divide it by x. So that means it's going to start by 1 less power. This represents x squared now. So this is 2x squared. So what do you think this represents? X. So that's going to be plus 9x, and that's just a constant, plus 12. And then this is my remainder, plus, because it's positive, 13 over, what did I divide by? X minus 2. Don't use anything up here in synthetic division right here. Don't use anything up here. Go back up here and put that in your denominator right there, right? So then there's my final answer. 2x squared plus 9x plus 12 plus, oops, that's too long, 13 over x minus 2. So now we want to simplify with positive exponents only. We want to simplify with positive exponents only. So to do this, we're going to get rid of our negatives, negative exponents. So here, negative 11 squared. No negative exponents. Don't need to worry about moving it from top to bottom or flipping anything. We just leave it there. But what is it? What's being squared here? And notice the next question here. This is negative 11 squared with no parentheses, and this is negative 2 in parentheses squared. Again, I'm always going to ask those on a test if I can, to make sure we get this straight. Only the 11 is being squared. The order of operations say you do exponents before you multiply. A negative sign is like multiplying that number by negative 1. An exponent, like the 2 squaring, is an E in PEMDAS, or please excuse my dear Aunt Sally. So really the 11 is times itself, and what's stuck out front? A negative sign. So then you have a negative 11 times a positive 11, and negative times a positive is what? Negative, and then... And then what? What is 11 times 121? So that answer is negative 121. But the next one, this whole thing is raised to this power, right? So that means we take the negative 2 and multiply it by itself, and that equals a positive 4. A positive 4. So those two, you got to know what's what, and then the next several problems, all of them except this one are all just rules. Do you know your rules? What is anything here? All of it's to the 0. So what is anything to the 0 power? 1. You're either going to get that right or you can get it wrong. There's no work to show. You either get it or you don't. I'm going to show a step here, even though many of y'all will skip it. M to the what? Each M has its own power. So that's when I add exponents. M to the 6 plus 7 is M to the 13th. M to the 13th. And then over here, C to the 6th to the 7th. Here it is 1C and 2 powers. That means we're going to multiply those exponents. C to the 6 times 7 is C to the 42nd power. C to the 42. And then the next one, first one on the next row, we have X to the 23rd, X to the 9th. We're dividing like basis. So we take those 2 powers and we subtract them now. So we have X to the 23 minus 9. And I'm going to put that in the top, the numerator, because the bigger power is up top, right? Not going to be anything left over in my denominator. 9 of these, get rid of 9 of these, and then 23 minus 9 is 14, right? That's what's going on there. So this is just X to the 14th power. So w to the 5th over w to the 12th. Again, no negative exponents. Again, w's, each with their own exponent. We're going to subtract. But this time, where are the w's going to be left over? In the bottom, because 12 is bigger than 5, right? So we're going to have 1 over w to the 12 minus 5, which is going to be 1 over w to the 7th power. So the next one is the one that's not the rule on this little section of problems right here. Not a rule. It's got mixed rules here, but we're going to take one term, right? That's 3 factors. 4 is a factor, x to the 8th a factor, y is a factor. We're going to take that, and we're going to multiply it by, again, one term. We got a negative 11 is a factor, x to the 7th, y to the 7th. 3 factors again. So when we have one term times one term, we take each factor individually that are alike. So we take the 4 and the negative 11, and we say, okay, what is 4 times negative 11? Well, a positive times a negative is negative. 4 times 11 is 44. And then we take the x to the 8th and the x to the 7th. What do I do when each x has its own exponent? That's what I did here. I add, right? So we're going to say this is going to be x to the 8 plus 7 is 15. And then the same thing for the y's. You got a 1 plus the 7 gives you how much? 8 indeed. So negative 44, x to the 15th, y to the 8th power. And we're going to put that in my answer box. X to the negative 12. Now we have a negative exponent. When we have a negative exponent, we move it. We move it where? Well, this is really over 1, right? So I'm going to move it to the bottom. This is now going to be over x to the 12th. And if I move everything out of the top, or the numerator, and put it in the denominator, what's left up top in the numerator? Just a 1. So 1 over x to the 12th. That's just a rule. Do you know what to do when you have a negative exponent? You move it from top to bottom or bottom to top, depending, numerator to denominator is what we just did. It was in the numerator at the top. We moved it to the denominator at the bottom. So the next one's got PVCs in it, 7, 21, got some powers. So again, one term over one term. There's no pluses or minuses to separate the terms. There's a negative up here, but that's a power. That's not separating another term. So then we take the 7 over 21. Does anything go into both of those? 7 does, right? It goes into this once and this time 3. So right now I have a 3 down here. I'm not going to put the 1 up top unless everything divides out up top. Then I move on to my p's. I got p to the 9th over p. Well, you subtract them, right? That's going to be p to the 8th up here, right? This is going to become up top of p to the 9. I can't, that's too jumbled there. Okay? P to the 9 minus 1. And then, what about the v's? Well, look, this one is going to move down, is it not? So it's going to be v to the 6th, and the v to the 9th stays at home because it's positive. Don't move it. It's a positive exponent. Leave it down there. And then what about c to the 12th over c to the 12th? Well, look, 12 minus 12 is 0. Anything to the 0 power we said was 1. So, or you could say that divides out to 1. Anything over itself is 1. So the last thing I need to do is put these two terms together. And again, with like bases, I add the exponents. This is p to the 8th over 3v to the 6 plus 9 is 15. P to the 8th over 3v to the 15th. So here we have a parenthesis to a power. Inside the parenthesis, again, one term over one term. So then 8 over 12, what goes into both those? That's right, 4. So 4 goes into 8 twice and 12 3 times. So what we're going to do is we're going to still have the negative 2 power on the outside. We haven't taken care of that yet. So we're going to have 2 over 3, and then c to the 5th over c cubed. That divides out and becomes a c squared up here, right? 5 minus 3 is 2. And then this d to the negative 9 moves where? Down here to become d to the 9th. What happens to this d? Stays in the bottom, right? It's a positive exponent. Don't move it. And again, we got to simplify those d's in the denominator before we move on. So this is going to be 2c squared over 3d to the 10th, all to the negative 2. So then I want to change this. I'm going to have this still have a fraction, but I want to change it from a negative 2 to a positive 2. How do I do that? Well, again, everything in the bottom top, everything top bottom, numerator to denominator, denominator to numerator. So I'm going to just flip it. 3d to the 10th over 2c squared, and then that becomes a positive 2 power. And then the rule for, again, one term over one term, that rule says, hey, you can apply that squared to every factor. So 3 squared, d to the 10th squared, 2 squared, c squared squared. So look, don't get this confused. What is 3 squared? That's not 3 times 2. That's 3 times 3, which is 9. And then d, now you multiply those. 10 times 2 is what? 20. Over, again, this is 2 squared. That's 2 times 2. That's this 2 times itself again. Not 2 times the power. So it's 4. And then c squared is c to the 4th. So 9d to the 20th over 4c to the 4th. Nothing else divides out, so we're done. 9d to the 20th over 4c to the 4th. Write in decimal notation. So this is scientific notation. So when it's times 10 to a power, so 9.87, 10 to the negative 3. That means this number, 9.87, is bigger than whatever the number is. It's times, negative exponent. So we're going to move it 1, 2, 3. We'll make it smaller. Zeros, put 2 zeros there. So we got what? We moved it 3 decimal places. And it's got to get smaller because it's times 10 to a negative exponent. So 0.00987. So here, 5.2 times 10 to the 4th. We write down 5.2, and it's got to go 1, 2, 3, 4. Well, that's going to be 52,000. So here, now we have 130,000. We're going to write it in scientific notation. Well, the decimal is understood to be right here, right? So we say 1, 2, 3. We go to the comma, but don't count the comma. 4, 5. I want to put it there. 1.3. You always want one digit left of the decimal, not between 1 and 10, basically. There's one digit. One digit. That's why that's scientific notation. A part of the reason. So this is going to be 1.3 times 10 to the how many? How many did we move it? 1, 2, 3, 4, 5. 1.3 times 10 to the 5th power is my scientific notation there. I don't know why I wrote 6 there. Got a 5 right here, don't I? So it should be 1.3 times 10 to the 5th power. And then I also want to move this one. Let's see. Got to move this here. We're going to say, okay, look, this has got to go 1, 2, 3, 4, 5 spaces. So this is 9.51 times 10. Since it got smaller, it's negative. I got 1, 2, 3, 4, 5. 9.51 times 10 to the negative 5 exponent. So 9.51 times 10 to the negative 5. So then here we have two scientific notation numbers multiplied by each other. We want the answer in scientific notation. So again, one term and one term. We can do the factors. So we're going to take the 4 times the 3. What is 4 times 3? It's 12. And then we're going to take 10 to the 5th and 10 to the 7th. So what's that going to be? Times 10 to the 5 plus 7 is 12. But wait a minute. How many? Here's my decimal. How many numbers are to the left of that? 1, 2. We don't want that. We need to move that decimal place over 1. We need to move this decimal place over 1. Oops. That's where we wanted it. It's here. Move it over 1. So if I do that, that's like dividing by 10. So I got to make up for it on the other side by multiplying by 10 over here. So it's going to go up on the power. So it's going to be 1.2 times 10 to the 13th. So it changed 1, right? It went from 12 to 13. Because, again, I moved this one place over, so it's either got to go to 12 or 11. I mean, 13 or 11. I don't know why I put a decimal 10 to the 13. 1.2 times 10 to the 13 power. And that is your review for test 2 in intermediate algebra. So, good luck.